So our next chapter deals with the topic electrolysis. So what is electrolysis? Basically, we know that water is made up of two substances, hydrogen and oxygen. So we cannot separate it by any normal method, just like we have studied in the lower classes in class 6 and all, that if you want to separate the constituents of a mixture, we can use variety of processes such as hand picking, sieving, and many other processes are there. But in case of compounds, how can we separate the two components? So the process for it is electrolysis. For which type of compounds? For compounds which can conduct electricity through them. Mostly electrolysis is done through such compounds only. So we might have a question that water is not a good conductor of electricity. So how does it get broken up into its constituents? So that is what we are going to learn in this chapter, how it is done. So electrolysis is the breaking of compounds into its constituent elements by using electricity. So this electricity is not passed through only a wire, it is actually passed through a liquid which is known as electrolyte, which we are going to learn. So first of all, let us understand the basic difference between the movement of electricity through a conductor. Conductor can be a wire, a metallic piece, or anything which is which can allow electricity to pass through it, which is metallic in nature or which can allow electricity to pass through it. That is called a conductor, as you all know. So we will learn what is the difference between the type of electricity or the movement of electricity through a conductor and through a electrolyte or through the liquid which I just told you about. So let's see. In the first figure, as you can see, the rectangle is actually a small part of a wire which has been magnified in order to understand, and it is connected to a battery. As you can see, the positive terminal is the longer side and the negative terminal is the shorter side. As you know, electrons move, and because of that current passes. Current is actually a phenomenon, but electrons are actually moving. Current is not something which moves. Current is just a phenomenon which is observed. It is an observation, but the electrons are actually moving across the conductor or across the circuit. So we know, since electrons are negatively charged particles, they will always move from the negative terminal towards the positive terminal of the battery. That means in our figure it will move in this particular direction. The electrons will move in this particular direction, right? From the negative side it will move again to the positive side. It will happen somewhat like this, isn't it? So what happens? The movement of electricity and the movement of current is the movement of electrons and the movement of current is just the opposite. In this case, like I showed you with the green color, the electrons were moving from the negative end to the positive end. The current electricity or current will move from the positive terminal to the negative terminal, as shown by the black arrow. So the black arrow actually represents the movement of current, but the green arrow which I just drew, that represents the movement of electrons. So do you think that all types of electrons will move in a conductor? No. Only electrons which are free in nature, only they can move, and because of those free electrons current is actually produced. So what are these free electrons? As we know, generally the conductors are elements such as copper, iron, etc., whose structure you haven't studied yet. So they have a quite complicated structure and their structures are quite large. So what happens? The outermost electrons, the electrons in the outermost shells, they are very loosely bound to the atom. That means the nucleus does not exert a very strong force of attraction on those electrons, which are in the outermost shells. As a result, what happens? Those electrons can move freely. Since they do not have any force keeping them intact, they can move freely through the conductor. So the blue color dots which I have made in the figure, those are actually those free electrons. So since these free electrons are moving, this movement creates current electricity. So what do these red dots mean? The red dots are the other atoms which are stable, which are not moving, they are stationary. Okay, so the atoms are stationary, but the electrons, the free electrons specifically, they are moving. From which direction? From the negative side to the positive side. So the electrons, the free electrons are moving in this particular direction, from the negative side to the positive side. Okay, so what will happen? Since the electrons are moving across the conductor, current will start flowing in the opposite direction. So this is the movement of current through a conductor. But what happens in case of a electrolyte? So what is electrolyte? Let us understand that first. Electrolytes are substances which, when dissolved in water or which are present in the molten state, can allow electricity to pass through it. So what does these two things mean? Dissolved in water means it is mixed with water and it is made into a solution. But what does liquid form mean? Liquid form means that the substance is melted, it is heated, and the solid substance will get converted into a liquid, and then also it allows electricity to pass through it. So this is the difference between a solution and between a liquid form. So whenever such certain substances are there through which electricity can pass, when they are either dissolved in water or they are molten, such substances are called electrolytes. There are a variety of examples: acids such as HCl, H2SO4, H2CO3, although it is a weak electrolyte, but it is an electrolyte. Then we have bases such as NaOH, KOH, etc. Then we have salts like sodium chloride, the common salt which we consume. Then we have magnesium chloride. There are many such examples. Okay. So using these substances or using these compounds, we can easily transfer electricity, and this phenomena is used in our inverters, in our car batteries, etc. You will learn about all these things in class 11 and 12. So the liquid through which electricity is passing is called an electrolyte, as you can see over here in the lower diagram. And there are two metallic rods inside that electrolyte. One is the cathode and one is the anode. We will learn about it later. And that is connected to a circuit, to an external circuit which contains a battery. Over here two batteries have been shown, but we can also have a single battery or you can have a group of batteries. It does not matter. So what happens? Again, same. So in this case there are no free electrons in the liquid. The liquid contains something else. What does it contain? In the chapter where you have studied about the various types of bonds, electrovalent bond, covalent bond, coordinate bond, you have studied that polar covalent compounds, whenever they are dissolved in water, they can break apart into ions. Yes, and also if we are mixing NaCl or if we are mixing MgCl2, that means the electrovalent compounds, even when they are dissolved in water, they will also break up into ions. So as soon as certain substances which are electrolytes, they are dissolved in water, they will form respective ions. For example, if I consider the example of sodium chloride, NaCl, when NaCl is dissolved in water, it will form two ions. One will be Na plus sodium ion and one will be Cl minus ions. So just imagine you are mixing NaCl in water. So what type of ions will be present in that water? Sodium ions and chloride ions. Both of them will be present. And these ions are solely responsible for the transfer of electricity in the liquid. In case of conductor, it was the free electrons which was transferring electricity, but in this case it is the ions, the ions which are transferring electricity. We will learn about this in the later stages. So what are these two electrodes? What are their names? We are all going to learn. So these are the basic differences between transfer of current through a conductor and transfer of current through an electrolyte, or through that liquid which contains ions in it. Until and unless the liquid contains ions, electricity will not pass through it. For example, if you make a sugar solution, sugar is not a polar covalent compound, so it will not form ions, it will not dissociate into ions, rather it will form molecules only. So molecules cannot transfer electricity. So sugar solution cannot transfer electricity. Honey can also not transfer electricity through it. There are many other such examples which do not break up into ions, and hence they do not allow electricity to pass through them. So those are called non-electrolytes. Substances which do not allow electricity to pass through them are called non-electrolytes, which even when dissolving in water or in the molten state do not conduct electricity. So let's see about the differences between metallic and electrolytic conductors. We just learned about it. So flow of current consists of a large stream of electrons. In this case, in case of metallic conductors, there is only free electrons, which causes the transfer of electricity. But in case of electrolytic conductors, it is the ions in the solution which allows electricity to pass. In case of metallic conductors, the metal can either be in the solid or in the liquid state. That means if you melt iron, you will get a reddish fluid, hot iron. Even through that, electricity can be transferred. Electrolytes, on the other hand, they cannot be used in solid state. You cannot pass electricity through solid sodium chloride. You have to either melt it or you have to dissolve it in water. Metals can be used both in solid and liquid form, but electrolytes can be used only in the solution form. That means when it is dissolved in water, or when they are molten, when they are heated and they are converted into its liquid state. This is a very important difference. No change in form or composition occurs during the conduction of electricity. So when you are passing electricity through any wire, there is no change, no chemical change, it is a physical process. But in because no new substances are formed, just the electricity is passing, so no change, no reaction is occurring, nothing. But in case of electrolysis, or in case of an electrolytic conductor, there is some change. There are new substances formed on those two electrodes, right? We learned about those two electrodes in the first page. There are two electrodes, as you can see. One was connected to the positive end of the battery and the other was connected to the negative end. So both these electrodes will have some particular deposition. So what will get deposited, we will learn about that. So there are many examples of electrolytes. Over here, CuSO4, copper sulfate solution. So whenever they are dissolved in water, it will form Cu2 plus ions, copper ions, and sulfate ions, SO4 2 minus ions. So whenever any substance is dissociating into ions, it will be a electrolyte. So what is electrolysis? I told you, it is the process of decomposition of a chemical compound, or you can say breakdown of a chemical compound into its constituents only when it is in its aqueous state or in its molten state and electricity is passed through it. Electrolysis. Lysis means breakdown. Electro means using electricity. So electrolysis, breaking of a substance, breaking of a compound into its constituents by using electricity. And I also told you about what electrolytes are, which allow electricity to pass through them only in the solution state or in the molten state, and which do not allow, they are non-electrolytes. So there are some examples of electrolytes over here. This I will urge you all to study it by yourself. So non-electrolytes do not have ions, they do only produce molecules, and molecules cannot conduct electricity through them. So now we have another table of difference: strong electrolytes and weak electrolytes. So what is a strong electrolyte and what is a weak electrolyte? As the name suggests, strong electrolytes allow a large amount of electricity to pass through it, obviously, but a weak electrolyte allows a very small amount of electricity to pass through it. Why does it happen? Because strong electrolytes consists completely of ions, but weak electrolytes consist of ions as well as molecules. They do not just contain ions, but they also contain molecules. In the chapter acids, bases and salts, we have studied that acetic acid is a very weak acid. Why? Because whenever it is dissolved in water, it will form only one hydronium ion, but it will also form acetic acid. It will also form acetate molecule, or you can say acetate ion, which is not a very good ion for conducting electricity. So that will be a weak electrolyte. Acetic acid will be a weak electrolyte. So all the organic acids like formic acid or tartaric acid, they are all weak electrolytes. But all the mineral acids such as HCl, then we have H2SO4. I am not considering HNO3 because it has some different properties. So these two, and if you consider bases, strong bases such as KOH, NaOH, etc., salts such as NaCl, etc., they are very good conductors. They are very good electrolytes. These solutions contain only free mobile ions, yes, which I just told. Strong electrolytes contain only ions, but weak electrolytes contain ions as well as molecules. So since strong electrolytes allow a very good amount of current through it, so if you connect a bulb here, just imagine in this figure, if you connect a bulb here, in case of a strong electrolyte, the bulb will glow very brightly because a lot of electricity is passing through the circuit. But in case of a weak electrolyte, since the amount of electricity is less, the bulb will not be very bright. So this is also a way through which you can understand and differentiate between a strong electrolyte and between a weak electrolyte. So there are certain examples. I told you about strong electrolytes already. Coming to weak electrolytes, all the organic acids such as acetic acid, oxalic acid, and in case of mineral acid, carbonic acid, I told you this is a very weak acid, so it is a weak electrolyte also. Bases such as calcium hydroxide, ammonium hydroxide, although they are good bases, but they are not very good electrolytes. And salts such as sodium carbonate, sodium bicarbonate, simply you can remember if it is NaCl or it is MgCl2, it will be a good electrolyte. CuSO4, these are good electrolytes, but the others are generally not very good electrolytes. So as we go through the chapter, you will be very easily able to differentiate between a good and a weak electrolyte. Next, we are going to learn about some non-electrolytes. I told you sugar solution is a non-electrolyte. Then honey, it is also a non-electrolyte. Then we have kerosene, then alcohol, then benzene. Benzene is an organic compound. You will learn about this in class 11. Then urea. Urea is also another organic compound. It is actually used as a fertilizer. Even if you dissolve it in water, only molecules will be produced. So it is not a electrolyte at all. Next we have the electrolytic cell, which was there in the first part. So this is the electrolytic cell, this particular thing. It is called an electrolytic cell. Cell means a battery, isn't it? But this doesn't look like a battery, but it is also a battery. I think you have all studied in class 7 most probably about a dry cell which contains a paste inside. That paste is actually an electrolyte, right? If you cut open a pencil battery, you will find a sticky fluid, not a fluid actually, a paste like thing. You shouldn't do it because it is quite risky if it gets into your mouth or something. So that sticky thing inside a pencil battery is called the electrolyte. Okay, so similarly we are going to learn here also about an electrolytic cell, this structure, whatever we have seen. What are the various parts of it? Let us see. So the liquid which is present, I told, it is the electrolyte, and there are two metal rods or metal wires. It can be a metal wire also. It can be made up of something which is conducting, which can allow electricity to pass. So those are called electrodes. There are two types of electrodes, a cathode and an anode. So as you can see in the figure 6.1 in your book, anode is the electrode which is connected to the positive end of the battery, and cathode is the electrode which is connected to the negative end of the battery. This is the most important thing that you have to remember. Other than this, you don't have to remember anything else. It all depends upon practice. So cathode is the one which is connected to the negative side of the battery, and anode is the one which is connected to the positive side of the battery. It is very, very essential that you learn it by heart. This is what will be used in the chapter in the most amount. Next, the device or the beaker in which that electrolyte has been placed and the electrodes have been placed, that device or that structure is called a voltmeter or an electrolytic cell. So this can be a possible board exam question also. Voltmeter. You have studied in the lower classes about ammeter, voltmeter, etc. That is voltmeter, which measures potential difference. It measures things in volts, but this is a voltmeter which allows electricity to pass through the solution and then perform the chemical reaction. So it converts electrical energy into chemical energy. Yes, in an electrolytic cell you are passing electricity and you are getting chemicals, right? Something is being produced on those electrodes. So over here, what is the energy conversion? Electrical to chemical. Very important. This is an electrolytic cell. And what is an electrochemical cell, which we have used in the lower classes, which we use in our day-to-day lives also? It is a device which is used to convert chemical energy into electrical energy. Yes, when you use a battery inside anything, inside a remote maybe, so what is happening? The chemical which is present inside the battery, that electrolyte which I was talking about, that pasty substance, that is actually converting into electrical energy, through which we are able to change the channel using our remote, increase the volume and all. So in case of electrochemical cell, chemical energy, that is the paste, is getting converted into electrical energy. But in case of an electrolytic cell, the opposite is happening. Electricity is being allowed to pass, and because of that electricity, the substance is breaking apart. That means chemicals are formed. So electricity is converting into chemical energy. Very interesting. So now these electrodes are those two metallic rods, or maybe something else can also be used. We will learn about it. They are dipped into the solution. They are not placed above it. They are dipped into the solution. And the electrode which is connected to the positive end is called the anode, and the negative end one is called the cathode. Very, very important. So which one is what and what are its differences? Let's see. Anode and cathode. Let's see its differences. It is the electrode connected to the positive terminal of the battery. Anode is that, and cathode, it is the electrode which is connected to the negative end of the battery. Now you have studied in the lower classes about anions and cations. Anions are the negatively charged particles and cations are the positively charged ions. Sorry, not particles, ions. So cations can be ions of sodium, Na+, Mg2+, all these are positively charged ions or positively charged atoms. So they are called cations. and negatively charged are chloride ions Cl minus, Br minus, all these which are negatively charged. These are called anions. So cations will move towards the cathode C2C and anions will move towards the anode A2A. Very easy to remember it this way. So if you remember which one is the cathode and which one is the anode, you can very easily remember cations will move towards the cathode and anions will move towards the anode. This is what will happen, which we'll learn. Also, cathode is called a reducing electrode and anode is called an oxidizing electrode. Why? In case of anode, oxidation takes place. Electrons are lost. How to remember this? This is my way of remembering. Oxidation, there is a huge O at the beginning. O means 0. Something is getting decreased, something is getting removed. That's why it is becoming 0. So electrons are removed. Electrons are removed and we are getting a huge hole out there. So oxidation means removal of electrons. And obviously reduction will definitely mean the gain of electrons. This can be a trick to remember, but you all can follow whatever you want to do. So oxidation means loss of electrons and reduction means gain of electrons. So in anode, in the electrode which is connected to the positive end of the battery, over there will be loss of electrons. How, what, whatever questions we have now, we will learn in the later parts of the chapter. So in case of anode, it is oxidation. Electrons will be lost at the anode, but in case of cathode, it is reduction. Electrons will be gained by the cathode. The cathode will gain electrons, but the anode will lose electrons. So anode is also called oxidizing electrode and cathode is also called reducing electrode. So this is the difference between these two. So now what are cations and anions? I already told you cations are the positively charged ions and anions are the negatively charged ions. Cations will move towards the cathode C2C, anions will move towards the anode A2A. In case of anode, what is happening? Loss of electron is occurring. So loss means it will begin with a 0. So oxidation. And in case of cathode, what is happening? Reduction is occurring. That means gain of electrons. So we are going to learn about all the other aspects of electrolysis in the next video.